Check your answers with mine. Hayden, go back to your seat. Check your answers with mine. If you have questions on any of these, we'll go over those. Number 1, you needed to simplify the square root of 8, but even when you did that, there was nothing you could combine together. So 10 times the square root of 7 plus 2 times the square root of 2. If you switch the order of that and put 2 times the square root of 2 plus 10 times the square root of 7, that's also fine. Questions on number 1? Okay.
Well, my question is for number 2.
Okay. Hold up. Number 2, there were different ways you could have done this. So you could have started to simplify and then multiplied at the end, or you could have multiplied and then simplified. So I did that way, multiplying 12 and 36 to get 432. The highest perfect square that perfect cube that goes into 432 is 216. The cube root of 216 is 6, and what's left is 2. So 6 times the cube root of 2 was your final answer. CK, what was your question?
It was because of the way you saw it.
Okay. Did you do it the other way?
I tried to simplify it first. Did it work?
Let's do that one. The highest perfect cube, you wouldn't be able to do it that way. We'd have to do just factors. So let's say 6 and 2, 3 and 2, times the cube root of 36. Yeah, but those aren't perfect cubes, so we would just be simplifying or writing out the factors. Okay, so then we need groups of 3. So we have one group of 3, one group of 2. So that one group of 3 would come out, that one group of 2 would come out, and there would be a 2 left on the other side. So either way, you get the same answer. One just has more that you have to do. Bella.
I thought the inside was
For adding or subtracting. Multiplying, that does not matter. Jenna.
Why wouldn't it be 19x2 2x2? Because
Can you
they're
explain for this one? I haven't gotten that far yet, so hold that question. Other questions on 2? Okay. Number 3. Simplify your 8x to the third and your 18x to the third. So if you're doing the shorter method, highest perfect square that goes into 8 is 4. So that would be 2. And bring down your 5. For your x's, 2 goes into 3 once. So there would be 1 on the outside and 1 on the inside. For 18, the highest perfect square that goes into 18 is 9. The square root of 9 is 3. Break down this 3. And then the same thing for these x's. 2 goes into 3 once with 1 left over. Putting all of that together, I just multiplied in this row. So 5 times 2 would give you 10. Times the square root of 2. Then we have our x times the square root of x. 3 times 3 would give us 9, times the square root of 2, then we have our x times the square root of x. Then, because we have things on the outside, those would come together to make 10x. Things on the inside would come together to make the square root of 2x. And then same thing here, 9x, 2x, and then we're only combining things on the outside when we're adding and subtracting. So 19x times the square root of 2x. Jenna and Peyton.
Why would the x not have a 2 above it?
Which x are you talking about?
19 and there's an x 11 and it's
Not multiplying. If we were multiplying, then it would be x squared, but we're adding.
when we're adding, we just do the numbers up.
Yes. Like combining like terms. X plus x is 2x, not x squared. Okay.
Are all the exponents twos and threes?
From the original,
Yeah.
this was a 3 and this was a 3.
And we added twos. But
There was an invisible 2, I just wrote it in. Charlotte? For these exponents?
Yeah.
2 goes into 3 how many times? Once. So this would be x to the first. With how many left over? So they have exponents, we just don't write them. Other questions on that one? Number 4, you had to multiply your length and your width together. Again, you could have multiplied and then simplified, or simplified then multiplied. So here, if you multiplied then simplified, this would be 12 times the square root of 90. The highest perfect square that goes into 90 is 9 and 10. So this would be the square root of, the square root of 9 is 3, times 12 is 36. And that would be your final answer. Questions on that one? Okay.
Well, I still have a question. Always be invisible two, not invisible three. Almost.
For the square root, there's an invisible 2, yes. It's assumed to be 2. If it's not a square root, it will have whatever the root number is. Other questions on 4?
Do you know the explosion question?
May. That's all I know. I don't know the specific date yet.
How many?
How many SOs? If memory serves me correctly, freshmen have to take 5 total. 1 math, 2 English, 1 science, 1 history. I think that's correct. But the English ones you take as juniors, I think. So just
You have to take one for science? Yeah,
Yes.
we did that last year.
Taking the math one
What if this takes up? Public school. Public school? Yes. Yeah, public schools do this. I know.
in Virginia. Virginia takes SOLs. Outside of Virginia, they take other things.
Like Florida takes FSA, it's just changing it now.
In Missouri, they call it.
In Ohio, it was a Ohio graduation test. But it was different because you took it as a 10th grader. Okay. If you haven't already, take out your notes from last class. We're going to finish those. And find the page that talks about distributing.
adding to x would be
We wouldn't be able to add those together. They're not like terms.
oh wait, we could only add this one as 4 and it would make it x for
It would be 2 x to the 4th. So just like when you combine like terms, 8x plus 5x is 13x. You don't change anything with it. Okay, so we're going to do a few of these, and then we're going to start on the review. So for example 1, if these were regular numbers or variables or whatever, we would take whatever's on the outside and distribute it here and here. We're going to do that same thing, we just have to remember our radical operation If we are multiplying a radical times a number that doesn't have a radical, that number is just going to come outside. So this would just be 3 times the square root of 6. We would not combine those two because they both don't have a radical. However, if we're multiplying two radicals together, we can multiply those numbers underneath. And then simplify. So this would give us 48. What is the highest perfect square we can divide out of 48? 16 and 3. Square root of 16 is 4. Could we do anything else with this? They don't have the same Vatican, so no. Before we move to example 2, what questions do we have on example 1? Same.
Why don't we simplify this into green and multiply that?
Simplify this one.
Yeah.
What are 3 factors of 6?
3,
Can we break this down anymore?
2. Yeah.
Do we have a pair? There's nothing we can do with that. Example 2. Now this one is a little bit more advanced, and you won't see one like this, but it is good practice for the distributing in general. We'll get more into things that look like this when we deal with our exponents in our next unit. But right now, we're just going to talk about how we would do this. So when we have 2 sets of things that we need to distribute, we're going to take the first term in the first set of parentheses and multiply it to everything in the second set of parentheses.
But not the first.
No. So if you want to rewrite that, that would be like 4 times 2 minus 3. 2 times the square root of 2 minus the square root of 3. And then you're also going to take the second term in the first set of parentheses and multiply it to everything in the second set of parentheses. So if we wanted to rewrite that, it would look like plus the square root of 3 times 2 minus the square root of 3. So we're taking it and distributing it twice. Because really you have to multiply everything together. This is the only way to really do that. So then we would distribute this first. 4 times 2 would give us 8. 4 times negative square root of 3 would be negative 4 times the square root of 3. Then we're going to distribute the second set. Square root of 3 times 2 would be positive 2 times the square root of 3. Square root of 3 times negative square root of 3 would be a negative square root of 3 times 3, both underneath. Do you have any questions on this so far? Then we can start to simplify. Square root of 3 times 3 would be the square root of 9. Square root of 9 is a whole number. That would be this 3. Now that there's nothing else to simplify radical-wise, we can combine like terms. I'm gonna do this above this because I ran out of space. So we have 8 minus 3. And negative 4 times the square root of 3 plus 2 times the square root of 3. Distributing will, distributing with 2 will not. We did a lot of simplifying and things, so let's check this in our calculator. We're going to put the original problem in our calculator and our final answer in our calculator. Make sure you're using parentheses when you put everything in. Make sure there are minuses and not negatives.
Does it matter if the 5 goes up in?
For this, put it in the front.
Why?
Just the format of how radical expressions are written, the constant will come in the front.
Will you tell me what if you were writing it at the end?
I'm going to say no, but I might write something on it.
Will you take off points?
It's so
I'm
confusing
going
in
to
my
say
head.
no, but I might write something on it. Do you get the same decimals?
Yes.
Say that one more time.
Why don't you just subtract 5 minus 2?
Does 5 have a square root? So because 2, yes, 2 does. The square root of 3. Our radical rules say we cannot add or subtract things that don't have the same radicand. 5 does not. So we can't combine them. That would be like me having 5 minus 2x and trying to combine them. They're 2 different things.
So if it's like next to it, so you can't subtract it.
Right. Right. We're going to do a few more of these examples. We'll do 13.
What do I just say?
17 and 18.
Oh, yeah.
It looks fun until you find that it's not.
So for 13, again, we're taking this and we're distributing it. Be careful here because you have inside and outside things that you're multiplying. So I would take this one step at a time.
Yeah, are we just taking the
That it's a whole term. You can't separate it.
So it's like the thing up here, right? With 5 minus 2.
Yeah, they're combined. It's like 2x. We don't usually separate that. So yes, we're distributing this entire thing. So we have negative 2 times 3 on the outside. On the inside, we have 3 times 10. And then our next term, we would have a negative times a negative would become a positive. I'm going to put plus 2 times 3. Or you can put negative 2 times negative 3. This would still become a positive. How you write that part doesn't really matter since the negatives will disappear anyway. And then underneath the square root, we would have 3 times 6. It's negative 2 times negative 3.
Is that what the second number we're doing?
Say that one more time.
What's the second number we're doing?
And 17 and 18.
Well, you said times negative 2. Negative 2 times.
Here?
Yeah.
Negative 2 times negative 3.
Okay.
So then we can start multiplying. Negative 2 times 3 is negative 6.
Yeah, I understand.
3 times 10 is 30. Negative 2 times negative 3 is positive 6. 3 times 6 is 18. As of right now, we cannot combine these because they don't have the same right hand, but we can simplify. Does 30 have a highest perfect square we can divide it by? Really?
Never mind, because you asked a question, and I don't know the answer to that question.
Okay. Does 30 have a highest perfect square we can divide it by? Can we divide 30 by 9? No. 15 and 2 would be factors, but neither of those are perfect squares. So let's say we went with 15 and 2. And then we broke down 15 again. Give me 2 factors of 15. 3 and 5. So we have 3 and 5 and 2. None of those can be broken down anymore, and none of those are a pair. So 30 cannot be broken down anymore.
Nine and two.
But 9 and 2 for 18.
No, but we didn't because you said we can't. What? You said we couldn't.
That is.
The square root of 9 is 3. And then we could simplify.
I got 18.
Yes.
Okay, and how did we get 18?
You have to do 6
Because
times
6
3.
times 3. Because 9 is a perfect square. 3 times 3. Oh, we just multiplied what's inside the radical.
Yes.
Right. Yeah, that's square.
The radicals for.
And then 2 times 3 is just the product of this.
Can we simplify this anymore?
No.
That is our final answer. With all of these, I would highly recommend that you put this back in your calculator. Make sure you get the same decimals. Because there's a lot of things that you're doing, multiplying, simplifying all over the place. You could easily forget something. So double checking yourself here is really suggested. Advise all of the above.
Number 18.
We're doing 17, then 18. Questions on 13 before we go on to 17?
I understand it. We're just. No taking 6. 1 taking multiplying 5. 3 and negative 4.
Yes.
Okay.
So we're going to rewrite that. Now, you don't have to rewrite this, but if it helps you kind of see it, I would do that. The 6 times the square root of 3 times 5 times the square root of 3 minus 4. Then we're going to do negative 2 times everything on the inside again. So negative 2 times 5 times the square root of 3 minus 4. Then we're going to distribute. So here we would have 6 times 5 on the outside, 3 times 3 on the inside, 6 times the square root of 3 times negative 4 would be negative 6 times 4. Actually, I'm going to change this.
Wait, where'd you get a 5? So much.
This 5.
Oh.
So I changed the way I wrote that. I put plus and then times 6 times negative 4. That way I didn't put negative twice and then it became a plus.
But were we supposed to multiply the 6 and 7 to 2?
No.
What do we multiply the negative 4 by? My hand.
6. And then I just didn't put the square root. Here. When everyone gets done.
Just don't. Just don't. Yeah.
Working second two, distribute those. And we have negative 2 times 5 times the square root of 3. And then negative times a negative would become a positive. I'm still going to write that they were both negative though, just so we see it. We're multiplying 6 times the square root of 3 more times negative 4.
What did you do?
So 6 times negative 4 times the square root of 3.
Wait.
Which step?
No. Yeah.
Let's start multiplying everything together. Now,
Okay.
if it helps you to see everything written out, keep doing that. But if you want to jump from this step to the next step we're going to do, where you simplify, that's fine. Whichever works better for you. So 6 times 5 would be 30. 3 times 3 would be 9. We have, this is negative 4. So this would be negative 24 times the square root of 3. Minus 10 times the square root of 3. Plus 8.
What did you
See there?
negative 8?
Where?
Oh no, it's negative
4. 4. We're just negative 4.
Okay, now it's combined terms.
So multiply this.
So we can do this together. And
So
then
6 times negative 4.
this
Oh,
together.
This is a
How do we? So then we do the. Negative 24 and negative 10.
You can do a couple different things. How you start to simplify this doesn't matter. If you want to combine your like terms first and then deal with this, you can do that. If you want to deal with this first and then deal with that, that's fine. That part does not matter.
Can we just do it
Sure. I mean, I'll do what you're talking.
You're still doing.
Let's simplify it.
Correct.
You sound so enthusiastic about this.
Right? Square root of 9 is 3. We can then multiply 30 and 3.
Oh, nice.
I'm not. I hate this with a passion. Don't
The square root of 9 is 3.
I'm happy.
My head hurts so much.
Combine your terms. 90 plus 8 would give you 98.
3.
Wait, what happened to the 24?
Haven't heard
Oh,
of it.
there's more.
And then for combining these like terms, negative 24 times the square root of 3 minus 10 times the square root of 3 would be what?
So 24 times 10.
No, not times. Subtracting. Negative 24 minus 10.
I don't know.
34.
Wait, we're doing this in the test, right?
Who?
So are we gonna have like 2
Okay,
questions
I'm
for this test?
It's only 2 objectives.
Oh, never mind. Ooh, test is next Tuesday.
Monday.
I'm sorry, Artemis. But the test is next Monday.
Next Monday?
It's Monday. It's Monday. Because next Monday would be like 2 Mondays from now.
I mean,
It's
yeah.
a Monday?
It's Monday.
It's my birthday.
This is the last class I have to learn. I have nothing.
I think I have my birthday on testing.
I have a Monday has been here. I have a test on my birthday, and the teacher let me take it the next day. I really feel
I'm so sorry.
this isn't fair. Thank you.
Do we have questions on 17 before we do 18?
You said it's looking for quick,
I'm not so thrilled about doing this. How many questions are on the test?
6 and 6.
That's so funny.
Okay, so that's one problem.
Same.
Have we done? No.
Thank God there's no one else.
How do you do word problem?
We just like.
At least there's no word problem.
Perimeter area.
That's right.
Alright, refocus. Number 18. 1. If something is square, that means it's taking itself and multiplying it by itself. So this would be the equivalent of 2 times the square root of 7 plus 1 times 2 times the square root of 7 plus 1.
So we're squaring the whole equation.
Yeah, this expression, but yes. So that means we're going to do the exact same thing we did in 17.
I don't know. I'm going a little crazy.
So when you do this,
This one's small.
2 times the square root of 7, multiply to everything there, and we
I'm supposed to like math.
Is that a 7?
Oh wait, that's not even part of the question. Let's grab the next one. What's the easiest?
So 2 times the square root of 7 times 2 times the square root of 7 plus 1.
Wait, don't you get the same answer?
Yes and no.
Huh? If we're doing it, no. Because
You'll see at the end why it doesn't.
where did the one go?
Then multiply 1 to everything here. Same reason we multiply -2 to everything here.
So then it's
We
just,
have to.
so then one of them is just the same.
Yes. But then we're going to simplify.
Okay.
I'm so excited for the test.
So let's multiply.
Yes.
Here on the outside we have 2 times 2. On the inside we have 7 times 7. 2 times 7 or 2 times the square root of 7 plus or times 1 would be plus 2 times 1 times the square root of 7.
Wait, does this say 7?
7 times 7 on the inside.
Is that 25?
Who knows?
Oh.
Multiply 1 times everything here, so we have plus 1 times 2 times the square root of 7 plus 1 times 1.
Okay.
Let's start. Can there be cubes for all of this?
Don't, no.
We're not doing cubes for all of these.
Not doing Okay, so it's 2 times 2.
I lost
7.
class.
So we have 7 times 7.
7 times 49.
49.
And then the square root of 49 will be 7.
Yes. We'll get to that in a second. 2 times 1 will give us 2. It's not. No.
No.
Wait,
There's no subtraction sign. There's nothing to cancel.
Where it says equal, it's just the same.
There's nothing that says equals.
Like, the very, very first.
Oh, okay. My bad. There's 2 times the square root of 7 plus 1
I think that helped.
in parentheses times the same thing.
Oh, okay.
oh, that's the deal.
So let's say we combine our like terms first. You don't have to go that route, but if you want to
Yes, it
knock that
does.
out, you can do that.
That's what I said.
This would give you 4 times the square root of 7 plus 1.
Wait,
Combine your like terms.
why did you circle 2?
Because they're like terms.
Are there more problems with this?
That was already answered.
There's no word problem.
Okay, thank you.
This is information library.
I want to finish out and just look.
Square root of 7 is, I'm sorry, the square root of 49 is 7. Then we can multiply 4 and 7. So 28. And then combine your final like terms. If you got a study together or review last class, raise your hand.
Wait, we're done?
With your hand.
Look at the paper. Just look at, you even got a sticky note on it. This is how far I got. This is how far I got. And because I was the teacher. Here we go. Basically, we just solved number 18, and the question solved itself because we squared it. When you square this, 7 squared is going to be 3. And then square root of that is going to be 7. So that's what social studies sucks. Dude, I hate my social studies class so much.
Do we have any questions on 18 before we go over the review? So we're going to go over some questions on the review, and then you have time to practice questions on the review and go through these.
This is even a lie.
So everyone should have this in front of them.
Oh, I'm only doing this. That's not wrong. I'm trying to turn myself up. I have this like major headache.
That's not it.
And I'm starting to get really in what class?
Alright, focus. Refocus.
It's really easy.
Okay. I would highly recommend that somewhere when you start the test, you write in as many perfect squares and perfect cubes as possible. That way you're not trying to remember them all.
We don't get them?
No. But yes, you have your calculator and you can find them all. But so that you don't have to keep finding them all, I would write them all out. So write as many as you know, 10, 12, 15. If you want to go all the way up to 20 for squares, that's fine. For cubes, 10 is good.
I needed to survive. Yeah. Huh? I just needed to feel something in my life. Oh, splitting a headache in the math.
I love now.
Bro, I don't even know. I got this right where she's writing.
Oh, I said I needed to feel something, not nothing for her. I'm gonna tell every part.
Should I miss class the other day, dude?
Yeah.
I genuinely like,
Don't swallow your.
I thought that was you choking.
Another chewing gum ever.
I just ruined the whole experience.
Yeah.
We're going to start off with number 3.
I can write where you're doing it. Like 169.
Not.
For number 3, you are simplifying this square root. Is 108 a perfect square?
No.
No. So we need to either break it down by factors or find the highest perfect square that we can divide 108 into.
Whoa, you are a lot harder than 36.
36 and 1.
Look up 30%, look down, and like the whole thing is just done.
I have a room by you.
That's also because you guys are talking a lot and not paying attention.
Oh.
Y'all just got called out.
I'm writing down and
36 and 3. The square root of 36 is what? 6. 6. We would bring down this 2. And then we need to simplify our variables. 2 goes into 9 how many times? 4. It's okay. With how many left over? 1.
Yeah, but.
2 goes into 2 how many times? Once.
Yeah, you're right.
And 2 goes into 14 how many times? 7. 7 with nothing left over.
Okay. I'm getting confused on how you're supposed to write the variables in the order.
I mean, this is
ABC
the
order.
final answer, but yes, ABC order. I mean, I'm kind of 2 goes into 14 how many times? 7.
So why don't we just write 6?
So anytime you do this, you're writing it as an
It's fine. It's going.
Okay.
We're living.
So now we can write what's on the outside. So that would be 2 times 6 times x to the 4th times y times z to the 7th.
Why does
14 go away. 2 goes into 14 how many times?
Oh, I didn't know you could do that.
It's okay, man.
On the inside, we have 3 times x.
So I put it X, Y, Z, even though there's different numbers. Or do I put Z, X, Y?
Do x, y.
Okay.
Okay, simplifying this, we have 12 x to the 4th, y, z to the 7th, times the square root of 3x.
Wait, why would we have to put the 3x at the back?
That's
Because
the format of simplifying
My
radicals.
mom yells at me that I'm not doing the math, and then I don't know how to do it either.
Terrible birthday present.
I haven't told you.
I'm sorry, Peyton. Happy early birthday.
Terrible birthday. And then also it's good.
I'm gonna give birthday boy some
Make Christmas to the education
like
system.
no
Like
test.
if he gets like
Dude,
a
don't come to
89, just
school.
round up to a 90.
Yeah.
We tried to help you round up your 89.
Sorry, because then I would have had to have done that for all of your birthdays, and I haven't done
My birthday's in the summer, so you wouldn't have to do that anyway.
Yeah, but what
Do we have any questions on number 3? We're gonna move on to number 5. Actually, Erica's next, and then you can go when she gets back.
Erica, you doing okay?
The real question is, are you doing it?
Oh no, absolutely not. I thought I made that clear.
Because my
Number 5.
and then so for number 5 you take the negative.
You don't know.
Put it on the outside.
We're gonna take the negative from this and put it on the inside. So that you don't have to worry about it.
Wait, what? How? Oh, never mind.
Is 16 a perfect cube?
Oh, right.
No?
No. So we have to find the highest perfect cube that we can divide out of 16. 8.
You're gonna ask why would I think about this?
Why is there -3?
Took the negative out.
Oh, right, we took it out and put it over. Okay.
The cube root of 8 is what? 2. And we're going to bring down this negative.
Oh yeah, that 8. No. 8.
Then 3 goes into 4 how many times?
What?
You want to-
1. 3 goes into 4 how many times?
Oh, for that reason.
Wait, how many left over? 1.
Is it too late?
That's an A on 9.
Huh? Wait, no, it isn't.
On the outside, you would have -2 times A. it was negative,
Because
and then we got
The
to
16 is negative. We put it on the outside and then you take it back in at the end.
on the inside we would have 2 times A. So you can leave it like this with all the dots in between, or if you want to get rid of the dots, you can do that.
So it's negative 2A cubed. Right.
Yes.
Yes.
Wait, why isn't there a 3 above the A?
3 above which A?
Because it's a cube.
Yeah. Oh, it's
Number 6.
That was fun. Wait, where did the negative?
It became negative.
Dude, you're gonna burp when you're it's just
Okay.
It's just gonna all go. Okay.
For number 6 is 320, a perfect cube.
No.
No.
Play now.
What is the highest perfect cube we can divide?
64.
64 what?
5.
Why do you know this?
Because I just did it.
Oh, you understand this?
Yes.
Yeah.
It's from also the divisibility rules.
Cube root of 64 is what?
Is this like intimidation?
The radius goes into 15 how many times? 5 times.
Oh.
With nothing left over. 3 goes into 7 how many times? Twice. With how much left over?
1.
1.
5.
So on the outside, we have 4 times n to the 5th times n squared. If you all would stop talking and pay attention, you would know that.
The 4 came from the 64.
375 is 64.
Times the cube root of 5 and n.
So 4 and 5 and 2.
Final answer is a flat.
And then it's parentheses, right? Because of the number.
So the parentheses you don't have to use, but you can.
Okay.
If you want to make sure they're separate, yes.
Wait, what's the final answer for 5?
The one in green.
That one time
Good point.
Questions on number 6?
Wait, do we have to put the? Do we have to put the square root over the other one? Like,
What was it about?
the 4 and the m.
That needs to be on the outside. Yes, you can either leave them in or take them out. It does not matter. You won't see them written in as a final answer though. Number 10. So number 10, we are now adding and subtracting. So your first objective is going to be simplifying radicals, cube roots, square roots with variables without. Your second is going to be your radical operations. Adding, subtracting, multiplying, distributing. So with this, we need to see what we can simplify. We can simplify 125 and 45. Is 125 a perfect square?
Yes. No. It's a perfect cube.
The perfect cube. What is the highest perfect square we can divide out of 125? 25 and 5.
Start swallowing them all.
25 and 9. 5. Oh, 5.
Square root of 25 is what? 5. And we're going to bring down the 7.
Oh. Did someone just fall?
And then we need to break down the square root of 45. What is the highest perfect square that goes into it?
9.
9 and
Five.
5.
So it's sinking.
Square root of 9 is what? 3. And we're going to bring down this -2.
So they all are even. Okay, we can simplify now.
So now we can simplify.
32 over 4.
We have 3 times the square root of 5 plus 35 times the square root of 5.
It's probably worse.
It's the thing.
Oh, I think the leaf.
Yeah.
Really? She thinks.
So
Minus 6 times the square root of 5.
32 over 5.
Not
I
divided.
just want to find this
Not over.
So you don't divide.
Okay, so I got
7 times 5.
I got -2 square root of 5.
Oh, this is.
Wait, what?
Double check that. Because you're doing 3 plus 35 minus
I'm at 2. Not 9.
It's 32.
Wait, what?
3 plus 35 is 38. 38 minus 6.
32. 32.
That's not the next one.
So, if you somehow happen to divide with this, that means it's automatically wrong, right?
Yeah.
There's no dividing.
Well, let's rephrase. You are dividing off the factors. You're not dividing final answers.
Oh, okay.
Okay.
Are we doing 9?
I like this.
For 9, it ends with like two different numbers under the radical, like a 3 and a 2. So does not order you
Wait,
You're really
at 35. 7. We are going to do 13. So for 13, we are now multiplying, so we need to multiply the insides together and the outsides together.
Thank you.
So we have 5x squared times 8x third. Multiply your numbers together first, because that'll make no sense.
It's a long one.
When you multiply your exponents, or your variables with exponents, you're adding the exponents. So you would have x to the power of 5.
Yes.
Yes.
Wait, multiply?
We'll get more into those rules next unit.
Yeah,
But-
but calculus plus 2.
The one.
Just
The one Friday.
Where did you put it?
Multiply.
5 times 8 because I'm like terms, right?
Is 40 a perfect square?
No.
No. What is the highest perfect square we can divide out of 40?
4.
4, yes. And 10. So that would give us 2 times the square root of 10. 2 goes into 5 how many times? 2 times.
2.
So the x squared, but how many left over? 1.
Is that it?
So on the outside, we would have 2x squared. On the inside, we would have 10 and x. I went ahead and simplified it. But if you had the dots in between, that's fine.
Next page.
11, 12.
Oh,
Next. questions on 13? Find number 11.
This is like fine.
We're gonna do 11 and 12, and then number 14 for you guys. I have to write 14 online.
Oh, we have to
So we're not gonna be able to draw.
No, it says like on our paper.
Yeah. I have to write.
Basically,
So we're gonna distribute number 11. The square root of 3 times 4 would just be 4 times the square root of 3.
What page is that?
The last page. I don't know. Yeah, because the number by itself goes in there. Okay. And then multiply 3 and 15 underneath the square root. So 45. Then we can break that down to what and what? The highest perfect square that we can divide 45 by 9 and 5. Square root of 9 is what? Can we do anything else with this? No.
Absolutely not.
That is our final answer.
Okay. So you can just put the 4 in the
Yes.
and
Yes.
That's what happens with me. Distribute.
Number 12, because it is squared, we have to write it out twice.
oh, what? Oh, we're good.
And then we're going to distribute twice. 8 times everything in the second set of parentheses. So 8 times 8 minus the square root of 2. And then negative square root of 2 times everything in the second set of parentheses. So minus the square root of 2 times 8 minus the square root of 2.
Yeah, I'm just. Okay.
Start distributing.
Wait, is that a negative in front of these?
This.
No, at the very top.
This is it equals.
So would the 8 become a negative 8 or
Which 8 are you referring to?
the way the second one?
This would become negative 8 times the square root of 2, yes. The 64 minus 8 times the square root of 2.
oh,
And then when we distribute on the second set, we have negative 8 times the square root of 2. The negatives would become a plus. And we have 2 times the square root of 2 underneath the square root. Plus. Again, if you want to combine your like terms first and then deal with that, you can. If you want to do it simultaneously, you can also do that. Negative 8 minus 8 would be negative 16. We have the square root of 4. My things have life.
it was so slower.
Square root of 4 is 2. And 64 plus 2 is 66. Minus 8,
Half a
yes.
second to crack it up. Is that the end? Is that the whole problem? 64. What is it?
Wait, I think this is problem. Is that positive 2 after the square root? Oh, no.
So we should get 66. Oh, we have to.
That's 66. Other questions on 12?
That's
Oh, it has the radical attached to it.
I would have been able to do that.
We're going to do number 14 and then we'll be done.
I'm not ready. Oh. You're having your this or
Yeah, the numbers are kind of weird, but 12, 13, 14, count them in order. On the same page. You're again distributing. So on the outside you have 3 times 5. On the inside you have 3 times 10. For the second set we have negative 2 times 3. And then on the inside we have 2 times 6. Start simplifying everything. 15 times the square root of 20 minus 6 times the square root of 12.
So is that 3 like a radical 3, or is that like just a multiplying by 3, or?
We're just multiplying by 3 times. Radical 3 is the key version. Break down 20, break down 12. Highest perfect square we can divide out of 20. 4 and 5. Square root of 4 is 2. Bring down your 15. That was supposed to be an arrow. Do the same thing for 12. Highest perfect square we can divide out of 12. 4 and 3. Square root of 4 is 2. Bring down your negative 6. And then simplify everything. So 30 times the square root of 5 minus 12 times the square root of 3. Can we do anything else with this?
No.
No. That is your final answer. It could be the same, and then you get 1. Could not. Also depends on how many things you have. Okay, so listen really quickly. You guys don't have much time before the end of class. I want you before Monday to work through any problems on the review or circle anything on the review. I would say try to work through it first. Bring it to class if you still have questions on it. So on the review or on that last set of notes, the multiplying and distributing things you didn't have a chance to practice. Work through any of that. Bring whatever questions you have on Monday, and we'll go through those as quickly and as fast as possible. You have a Khan Academy on due Friday. The Delta Math on radical operations is due. Make sure you work on both of those. For 1 second. And then come see me if you still need to finish a test or start test corrections today after school or in the morning, tomorrow, Monday, or if you want to go through any of this. That will go with your question.